Good morning, everyone. Thank you for joining today's June 22nd, 2018 VOLTHA call. We're talking about OpenOMCI and Technical Profiles. And just a note, we are recording the session, so it can be posted later to the VOLTHA playlist on YouTube. So keep that in mind during questions, discussion, and presentation. And with that, Chip, if you're ready, I will give you presentation rights.
Okay, I'm ready.
Great. All right, you should have presentation ability now.
Okay.
And I see your screen.
Okay, that's great. Okay, well, welcome everybody. Good morning and good afternoon. I've been talking some with Sean on, during some of the calls for the technology profiles and email on how we might actually try to realize this with the OpenOMCI and the MEs and how to create those. And we thought it was a good time to go ahead and make a little presentation on some of the work that's done so far, some of the things we got ahead of us, and probably some decisions we want to make as to just overall scoping of how best to do the work. So for proposed agenda, I wanted to, first off, some of the expectations, make sure we try to gauge exactly what we're trying to do since we have such an aggressive schedule. Then go over a little bit on OpenOMCI on how it actually sort of starts up, so we know about when, in the 2.0 when technology profiles should be applied to the hardware, the MEs created. Then go over a little bit of the service technology profile to mapping to the actual OMCI MEs that I've done so far. And these are based off of the little JSON output that Sean has shown in several different presentations so far. And then from that point, go in on how to break these down into tasks that run, over the OpenOMCI task runner to actually send the information down to the ONU for realization. And then follow that up with some of the other places in OpenOMCI where we have to also consider how the technology profiles affect it. One is in the MIB audit resynchronization in case we lose connection with an ONU, and how to restore service or verify that the service is running as we expect it. And then also as you start doing a lot of these internals, you do performance monitoring intervals as well as threshold crossing alarms. And of course, PM is just now underway, and some of the alarms are being defined. I just want to briefly bring those up. So is there any other topics that we'd like to add to this before we go on? Hopefully we'll have plenty of time afterwards for general conversations as well.
Thanks, Chip. It might be interesting to also talk about scalability. Let's say you have some kind of startup situation where there's a lot of ONUs coming up at the same time. Is there a way we can optimize the throughput to bring up lots of OLTs at the same time? I'm getting some echo here. Is that me?
Yeah. We can go into a few of those issues, and also some of the things I think we might want to look into on even how some of the OpenOMCI does timers that we might want to eventually change. It might actually be good in other people's statements, but I can bring that up when we get to the question section. So if that'd be fine. So
yeah, sounds good.
Okay. And let me write down that we want to do scalability so I don't forget. Okay. Well, to start off with, the first one is I just want to make sure that we understand what we're trying to do. So we've got two use cases defined, or at least two operators who've expressed that they'd like to have high-speed internet service, and that's AT&T and Deutsche Telekom. And we're pretty familiar with the AT&T. It's 4 classes of service where the ONU does a tag operation, and as well as Deutsche Telekom's 8 classes of service, but the ONU doesn't do any tagging, it just trunks the frames. And also in the technology profiles, there's mentions of also 2 classes of service and single gem port. So I don't think those are, we can obviously address those because they're just a simple subset of what we're working with, right, targeting. So one of the questions that we'd like to think about, and we don't really need an answer right now, but with the number of the traffic scheduling and prioritization options, different congestion algorithms, and also even the range of testing, various meter bands and how those are applied, as well with single multiple T-cont. We might want to try to think of how we can reduce that to what we really truly need out of the ONU with technology profiles for the 2.0 release, because the coding is probably not that difficult. I just see that the testing burden might become, somewhat exponential as we add features in. So as we start putting things together and, the 2.0 release date comes in, let's try to think of what we have to have in the first release as opposed to having everything. So does that seem pretty reasonable for everyone?
Sure.
Okay. And some of it is, and some of the reasons is as we get in towards how they're actually applied and some of the resynchronization efforts, the differences in OMCI stacks on ONUs and having to deal with those, that will always throw a wrench into how things actually occur. So I just want to make sure that we don't try to scope ourselves too big to get done what we really need. So for the service technology profile mapping, I made a first pass at what Sean had on his slides. Let's see if I can find those. And I guess if everyone can see that. Nice.
Hey Chip, just a quick note here that the OLT adapter would be taking in this technology profile, and then it creates an instance of that profile for an ONU to use. So the instance itself is going to have additional fields. It's going to have the ALEC IDs and the gem port IDs and and maybe some meter band information. But so there is a wiki page on the technology profile instance as well, just so people know. Sorry, go ahead.
Okay, yeah, thanks for that. And yeah, I was finding that and of course we can do shaping and traffic management at the ONU and also at the OLT. So we need to make sure we get the best service out of whichever piece we want. So and a lot of those parameters, I'm not the T-cont, the T-cont ALEC IDs. I'm not really interested at this time since they're mainly parameters that we feed in. I just wanted to try to identify all the various managed entities that we have to use and manipulate. So
sure, yeah.
Okay.
But yeah, it's just like for the additional bandwidth, for instance, if it's auto, then basically we're deriving the additional bandwidth from the meter bands, and then that would get added to the instance, profile instance. The result of that, if the additional bandwidth was not auto, is a specific value like best effort, then that would be the value used, right? So just the instance has things that are resolved in more detail.
Okay. Yeah. Okay. Well, yeah, and so this spreadsheet I'm showing is actually linked in the presentation I have. So hopefully everyone should be able to retrieve that from Google Sheets. And so this is pretty much, maybe you can take this, Sean, and add it to the general documentation as you best see fit. And I went ahead and crossed out the max gem payload size, and so I think you're thinking about that not being provisionable.
Yeah, that resolved itself away, basically.
Okay. And so without going really into great detail, to the left side, I pretty much have identified the ME. I didn't go down to the actual attribute settings that we need. So to the left side is the affected managed entity that has to be manipulated. And to the right, I tried to include a few comments or notes as we're working with these and what they mean in different scenarios, as if we have weighted round robin, then obviously the traffic scheduler's priority / wait field refers to wait. So I guess we don't, unless you really want to, we can go over these offline sometime, but I just wanted to make sure we present this. Are there any questions or?
I just wanted to point out that you know, the technology profile scheduling is kind of divided into two parts. One is the aggregate scheduler, so upstream that's the alloc ID / TCON scheduling, and there's then the per gem scheduling, right? So, and in the downstream there's an aggregate scheduler, which is kind of the equivalent of a TCON but downstream. There's no, you know, there's nothing on the pond that represents that, but within like an NP or some other component of an OLT, that the downstream scheduling could apply to that, and the gems and the downstream gems apply to queues in that other scheduler that may exist in, you know, like on the Qumran for the edge core OLT. Yeah,
and in your original presentation, you had some really good graphs of the various components things flow through. So that sort of goes into a nice high level of where a lot of these things are actually realized. So.
Well, that's right, I did. Thanks, Chip.
Okay, yeah, I did a lot of back and forth reading on that for sure. So, if I can go back to try to get some of these. Sorry about this. Okay, just want to make sure I got to the right. And for some of these MEs on how they're actually applied in traditional, or not really traditionals, but in ONU so far, it is the few ones that are open source pretty much had a script of MEs. They just went through and pumped down to the ONU to realize the service, and that derived from that as well. And as I converted it over to OpenOMCI, I started using Task to do this download of the service. And so I've split those into separate steps, and I have some pictures a little bit later on that I'll go ahead and show what the sequence they actually perform, and probably the sequence we'll have to have it towards the very end. And I'll be discussing that in just a few moments. But one of the things I wanted to go over through is how OpenOMCI starts up. And if anyone's familiar, typically when you have a new ONU, you have to go through a MIB reset sequence. And so I've gone through, and so far in OpenOMCI, we have a MIB synchronizer and also an OMCI capability state machine. And I wanted to present those two pieces of how they come up, and that's pretty much in the sequence diagram that that you can see to your side. So let me see if I can get a little bit better picture. So this is, if you're curious on how things actually go up, this is how OpenOMCI actually starts up with. Okay, that's MIB synchronization, my apologies. Pretty much when the device adapter starts OpenOMCI and gets its start command, it pretty much starts OpenOMCI, which registers an ONU device, and that's in charge of the communication channel and also the state machines. MIB synchronization starts up, and it's a high priority task, and its main responsibility is to find out if this ONU is either a brand new ONU that's never been around, or if it's a previously synchronized one that just needs to be audited and reloaded. So this shows just the overall general capabilities. and steps that these go through. And I put this together. One is that both the capabilities and the synchronization needs to probably occur before we apply device profiles. So the actual task of provisioning the bridge MEs, the various PON and Uni MEs should occur after this as a general step. And then in post 2.0 timeframe, we're looking at the possibility to be able to do pre-provisioning before an OU is synchronized, so that once an OU is synchronized, it would then automatically apply any data services. But that's a post 2.0 effort, just to keep things simple.
Chip?
Yes.
Yeah, I had a quick question. When you said that the ONU is rediscovered, I mean, I've seen it before, has to go through this audit step and
yes,
has to be synchronized. What exactly are you synchronizing and auditing?
That's synchronizing the MEs. So initially, when you initially discover, you do a MIB upload, and then from that point on, the OMCI MIB synchronization state machine watches all successful creates, deletes, and sets, as well as attribute value changes. And it begins to reflect those into the MIB database. And there's also a attribute in one of the ONU MEs called MIB data sync that is incremented on each change operation. So whether, even while you're up, every once in a while, you'll be doing an audit. And a MIB audit is also done when you come up and say, oh, this one's previously synchronized. Is it still have valid data? So you compare the MIB data sync values between the ONU and what the OpenOMCI thinks should be there. And if they're different, then you go through, do a snapshot of the OpenOMCI's MIB database, and request a snapshot of the ONU's MIB database and upload those, and then do a ME instance by ME instance comparison and to locate differences. So that's what the audit process is, and resynchronization is when you find out, that's when the differences occur, and if there are differences, you declare that the MIB is out of synchronization, and at that point you have since the OpenOMCI MIB database is the source of truth, it's responsible for doing a series of tasks to make sure that the MEs down on the ONU, properly.
So, okay, if an ONU goes away, the SDN controller may decide to remove all the flows, multicast groups associated with that ONU. If it comes back, it may choose to reprogram all of that, right? Now,
that's correct.
When it chooses to reprogram all of that, I would assume the adapters are going to look at, okay, fine, I got this flow back that I need to put in. Here's what I'll look at the technology profiles. I'll see whatever gem ports or TCONs I need to create, and it pushes all of that down there. So why does OMCI have to, other than changing, resetting your state machine, why does OMCI have to do all this work about being the source of truth? And I'm trying to understand, is it another brain that's sort of in there and doing things on its own, or the SDN controller is still the brain?
Yeah, well, it depends on actually how the failure is. If an ONU reboots, or if there's a loss of signal, so it goes, it falls off the pond and has to be rediscovered, the OLTs will actually rediscover that and start this ONU. It actually will should really create a new OMU instance and bring it up. So the MIB database there will have to be rediscovered because you cannot trust that that ONU is still the same ONU. But you have the case also that if you do a over, or if you just temporarily lose communication on the OMCI communication channel, so perhaps a timeout, or maybe, or some other issue, you might still have to resynchronize this.
So also that this creates some level of autonomy. So if communication is lost upstream to the SDN controller or otherwise, this at least can get minimal data path up and running for a subscriber again.
Yeah.
Well, I guess, do you want to do that? I guess we need to go through some use cases, maybe with the operators, in that, if the ONU goes away, right, and then comes back, the requirement is that you need to re-authenticate that user, right? So you really have to go back up to the SDN controller and re-authenticate and then re-download.
Is that a requirement? What if somebody unplugs their link in their office and just plugs it right back in? I mean, I understand, but is that a requirement for real?
Well, if something goes away, no matter how long, you have to re-authenticate.
Okay.
I would think.
So then, Sarah has a point.
And also, I think
Go ahead.
At least, I mean, in some models, the authentication is run external, and I mean, let's say in an RG, that's running the authentication for the subscriber itself, and it has a time in which it potentially authenticate. Now, depending on what state that RG is in, it depends on whether it potentially needs to authenticate. If that RG has no knowledge of what necessarily has happened and he's authenticated, necessarily have to re-authenticate.
Exactly. Otherwise, we're tying our entire vertical stack together, and any type of loss of upstream management connection, your subscribers are all hosed.
Well, I guess we need to have a statement from the operators whether, if you lose connectivity, you have to re-authenticate. Because if you don't, then basically I can switch out equipment. I could switch out my RG for some other type of equipment, right? And if the RG was doing some kind of limiting of the service, then now I have unconstrained access to
the RG itself is authenticated. Now, you're saying that one particular RG is authenticated, and then you switch it with something that is not authenticated and goes off and does things out of policy. Is that's the kind of action you're talking about?
Yeah.
I mean, that will absolutely fix the re-authentication, right?
Yeah.
ONU and RG are separate.
Without the problem, if we switch with the regular RG.
Well, so this is something to keep in mind here. Just in our testing, the authentication the RG does and the EAP that it does totally depends on whether the OMCI channel has been established, VLANs have been pushed to the ONU, and traffic can pass. Yeah. So until OMCI is synced up, and if the ONU is rebooted and let's say the RG isn't, the reestablish of OMCI, the communication channel, the tagging, and all of that has to be reapplied so that the RG can do anything at all.
Sure, but I guess the case that is maybe problematic is if I disconnect my RG and I connect it to a router or something else, right, on the Uniport. If I don't have to re-authenticate in that circumstance, now I have unconstrained access to the port, right, with my router.
Yeah, well, whenever there's a disconnection between the RG and the ONT, re-authentication will happen. So that's a current network policy.
I mean, the original
RG will initiate.
The original context was the ONU. We were talking about the ONU, not the RG. It's a completely different argument if the RG is taken down. If the RG is where the authentication occurs, the ONU is not, correct? So if the ONU, if the fiber goes down or somebody unplugs their fiber link on the WAN side of an ONU and plugs it right back in, this is one place to where the OpenOMCI, and what Chip's presenting can take back over, reflow, anything, resync the database, all of that thing, and nobody has to know the difference because the RG is still authenticated technically.
Yeah, that's the.
But it's absolutely true. If the RG chooses to say at that time I need to re-authenticate, it wouldn't be able to until the communication until the paths are up.
That's correct. That should work.
RG does not know the link is on the POM side is down.
Right. So it won't necessarily know
what you described about them.
So one of the things, I mean, I don't know if it's currently implemented, but it's being talked about with, going forward BNGs. The BNG will have an allowable MAC for that endpoint for the RG itself. Right? So you swap out an RG, it ain't going to work.
Yeah.
Unless you spoof the MAC as well.
But
and even then, it's only going to work until DHCP re-authentication time, which would be about 2 days.
So
I guess
go ahead, Sean.
I was going to say, so it really comes down to the policy of what the SDN controller is going to do once it gets told that the link is down, right? And if the policy is that I'm going to tear everything down, then it needs to come back up again and re-authenticate and re-establish all the data path and everything. If the policy is that I don't care, then we're back to, what do we do if the RG is disconnected, right?
Yeah, I think we can probably have a 2-hour deep dive.
Yeah.
Slightly. There's a lot of different things that could occur. I think if we try to keep the scope simple and allow Chip to proceed and explain, the capabilities of what OpenOMCI can do and how it can recover an ONU, and it gives you the ability, it shows you what we're capable of at that node in the network. But certainly, if you get a loss of signal, we're going to send any ONU adapter is going to send a loss of signal alarm up, and anything can happen from the controller standpoint. You can tear down that link, like you're saying.
Yeah, well, I mean, loss of signal, those are what will probably occur 9 times out of 10. But you also have the case if you do a disable of an ONU, you basically, disable it, but you don't remove it. So it goes to a port down, but the port is still there. Reestablish when you bring that port down. Right now, the VOLTHA will remove all the flow when you do the disable commands before it actually sends the disable request to the ONU or the OLT. So, in that case, Plum is still up and it's still running. You're not doing high-level OMCI because the device is disabled. And the next, when you go back and re-enable it, you need to go make sure that nothing has changed drastically. For one reason, you might have lost or missed out a bunch of autonomous messages coming from the ONU or a few changes. So in that case, you have that. Usually it's when you miss ADC is when you might have to, use the audit becomes important.
Yeah, so I have a note of the use cases we need to have a follow-up meeting on if you want to go ahead.
So, I mean, keep in mind also there is the case where the PON doesn't go down or the ONU doesn't go down. There's just a chip or just detects through the MIB audit a mismatch. So there is certainly a need for all the OpenOMCI for that reason.
And then in that case, do we need to just reset and reconfigure, or do we need to try and rebuild? That's another.
It depends on the failure, but like in an HA event, say you have to move a device adapter from one core to another, and you would like to have no data.
Yeah, so if we can't maintain the synchronization of the MIB sequence number when we do a switchover, then the audit would be very useful.
Okay. Okay, and we can go on just in.
So sorry, so I have a question. Is you are talking about the RG? Is it mean the SFU the on T, right?
No, well, so the device connected to the SFU. So it's
SFU is not RG, right?
Right.
No, well,
I think RG is it's out of scope. The first OpenOMCI spec.
Yeah.
Yeah, there is no RG configuration in the OMCI.
For bridge mode, right?
Yes.
It's just simple SFU with OMCI provisioning. There's no, we're not worried about the TR69 or wherever at this point.
Okay.
Okay.
Okay, well, let's go on and go and talk about how we actually sort of realize the service profile MEs within an ONU. And in OpenOMCI, there's a task runner that's in charge of running all the OMCI over the communications channel in order to do things, in order. And in some cases, when you like do the initial MIB upload, that has to be pretty much a synchronous task that it's an asynchronous task, but it has to do its entire steps without interruption and needs exclusive access to the channel. So that's the purpose behind the task runner with an OpenOMCI. And to realize a service technology profile, I see that being broken into possibly up to 3 different tasks. One is related to setting up the information that's fairly common no matter what kind of service that you will apply. And I'm pretty much calling those the bridge tasks because they pretty much center around the bridge implementation within the ONU. And to sort of show what that actually is, this is actually how the AdTran ONU used to come up and do a single gem service back in the 1.3 release. And in these, the S pretty much stands for a set ME and the C for a crate ME. And the numbers, the actual sequence that was actually applied, because remember, these used to be a script. And it's fairly similar, maybe not the exact same sequence as what the Broadcom ONU does. So it was very, it was pretty much taken from what we saw, from snooping our own lines, our own OMCI lines on a non-VOLTHA OLT and ONU. And some of the orders actually didn't make much sense, but sometimes it's very, very important to get things in a certain order, otherwise the stack just does not behave. And that's probably going to be one of the difficulties when we start working with some of the different variants of the Broadcom ONUs and other vendors' ONUs. They might want to do things in slightly different orders. So what I did, what we currently have up on for the AdTran sequence, I pretty much broke it into a couple small tasks where it first centers around setting up MAC layer bridge. Then it's responsible for setting up the gem ports and TCONs, and then the extended VLAN tagging, which is pretty much the flow information. So this is currently what we have up right now, but it's probably not ideal, but it has started to split things apart. And hopefully in the next implementation of this, and along with some of the work that Matt's doing on the Broadcom ONUs, we can hopefully try to get to a fairly similar or common sequence. And these MEs I'm showing are pretty much the ones I had in the mapping on that Excel spreadsheet. And this probably is the more desirable one that we'll probably try to look at first. And to the left, I pretty much have like the common in the tan set of tasks, followed by ones that are specific to high-speed internet, because likewise, we might want to implement other services besides high-speed internet. And the third one is the steps that manipulate information based on flows, whether it's the meter bands or the tagging operations. And then last of all, there's a enable or disable of the admin status on the Ethernet UNI. So that.
Yeah, I guess from a high level perspective from the ONU, for you anyways, so I mean, it needs to get the technology profile instance, which is basically setting up all that block on the right-hand side of the screen, right? And then it also needs to have the flow information, which then is setting up all the flows on kind of the left-hand middle side of the screen, right?
Yes.
And then you have the ordering component where you can't reference anything that doesn't exist yet. I guess the ONU stacks don't like that. So yeah, this is a nice picture.
Yeah, and you know, I've written these down either in code or on a piece of paper, just because if you change one order, it will fail if you do things in the wrong order. And then sometimes I've actually seen where you can implement and reference MEs that don't exist first, and then instantiate them, and it still works. So having, you know, I would suggest that as people work on their various adapters, they try to find some way to, maybe we get some common way to have a good picture of what we're able to do. So if when Matt or whoever works on some of the service profiles or myself on the Broadcom ONU, it'd be nice to see if we can have a simpler map and see where things might change. So that way, I guess Matt just arrives up and volunteering for a lot of work.
No, I heard you. GoToMeeting is flaking out on me, but I heard you.
Oh, okay. I don't want to volunteer you for too much, but you know, so this is some of the things that we'll probably be looking at probably towards, I would guess, the end of Sprint 4, starting with Sprint 5. And I think it probably would initially be best to, as we implement the common, with a common, and the common can probably be similar on both the ADTRAN and all the Broadcom-based ONUs. I would think high-speed internet section might be ONU stack specific, so we'll probably have to do the same task but slightly different for each ONU until we can find out exactly what works best for everyone. But then I think the flow task is probably going to be common, because that's actually the one that probably has the worst number of variables that have to be taken into and applied. So if that can be done as a single task for all ONUs, I think that'd be very advantageous, you know, for consistency.
Yeah, and there's certain operations that I guess that may be different from stack to stack too. In that, like for instance, if I do an admin lock on an ONU, I mean, you really need the ONU to do the right thing. So,
yeah.
That may be, yeah.
And part of, you know, what I had to do is when I actually did OpenOMCI, all of the state machines and all of the tasks are basically objects. So there is a base common implementation, and when a ONU registers, it can actually provide its own task that replaces one from OpenOMCI as long as it does it the same, or it can actually replace a state machine or just various portions, since you can derive from a task and just change a couple small variables in one method and get your desired behavior. So I think that this will probably help out as we start trying to keep some common code, but you know, break these steps up so that it's easier to customize on an ONU basis. And that probably only be appreciated by the developers as they start going through all the OMCI stack headaches that they might find.
Chip, just to kind of step back a little bit, in that, you know, we were discussing at the beginning where, you know, we really need to do the MIB upload before we can apply the technology profile and the flows to the ONU, just because we need to know, you know, the IDs of things that we're going to be using, right? I mean, and resources that the ONU has already created itself.
Yeah.
So it may be that, you know, it may be that we want to hold off reporting that an ONU has arrived until we understand a bit more about it, or we could report that it's arrived and create the port, but then we want, you know, we may not be able to apply the provisioning that comes down immediately. It would have to be held off until the state was correct.
Yeah. Yeah, I think that's sort of correct, and that's why I was wanting to say we might want to, you know, always do for 2.0 is start up the applying the technology profiles after the synchronization. We can provide some early information if it helps profiles, before mid-sync occurs, because obviously almost every device, every ONU is going to support the OMCI and OMCI 2G values. So a mini capabilities could always be performed before the full upload if that helps. But I think I would like to wait till after 2.0 to try to do anything that's streamlined or customized along those lines.
Yeah, I guess that also gets to the concurrency capabilities here, in that, if I have two ONUs that have been discovered and I want to provision them both, about the same time, can I do them both independently, or is it only one ONU that needs to have control of access to the OMCI?
No. Actually, how VOLTHA has split things up has made this a whole lot simpler. There's of course, on a single PON, there's only of course a single piece of a pair of fiber, but each ONU has its own communications channel, and the OpenOMCI runs in the context of the ONU. So before VOLTHA, you had all this OpenOMCI kind of capabilities running on the OLT, and it had to manage the hundreds or thousands of ONUs out there that were beneath it. Whereas this runs in the actual device adapter. There's one it runs in the device adapter, and each handler has its own instance, so they run completely separate of each other. So they all can be running through these state machines at any time, irregardless of what the other one's doing. And so the only shared resource is the proxy channel to the OLT, and then the actual OMCI, the fiber. And that brought me back to one of the points I pointed out earlier, is currently we're doing a lot of timers, are running, every 15 seconds or every, 3-second timeouts or whatever. Those are fairly fixed. Since the proxy channel, back to an OLT, and the OLT itself is a single network resource, we'll probably want to go through and add some skew to those timers, because whenever you have a shared resource like that and use timers that are fixed, there's a tendency for those timers to coalesce so that everybody starts doing their commands at the exact same tick, whereas they could really be spread out several milliseconds apart and be a whole lot more fair to the OLT. So that's something I'll probably look at is once we can start scale testing this.
So maybe this is a good time to chat about scale. I got concerns about how much data we're going to have to store per ONT and etcd.
That'll vary upon each ONU, but currently for the MIB databases, I think during an upload on the Adtran OLT, we have around 270 instances of various MEs, and there's a CLI out capability in there, so we can actually dump that. On the TNW Broadcom-based ONU, it has a lot of pre-created ones for all the different voice channels. It has a ton of things, so it has around 300 on the MIB upload. And then looking at this single service on a uni, you're probably adding about 12 more instances out there. So it's not a great amount of data, and except for like probably some in this picture, the sort of pinkish color, the flow ones, those are the ones that might be changing on a higher basis, especially once we do perhaps multicast data or IGM if someone does that. But I don't know if it's really that significantly amount of data. I'm not sure how we could get around that.
Yeah,
Well,
I mean, I'm not saying we have to spend a lot of time on it right now. It just, when we were going through it, I was like, it just had a concern. But if I'm wrong, I'm wrong. I'm okay with being wrong.
It's just really a question of, if we have millions of entries in etcd, you know, it's a different conversation, but, you know, what does that start looking like?
Well, it's also, it depends on how, once we get this implemented, on how we want to, because really the MIB database in etcd or console is there for HA. So if we actually go through and realize that, well, you know, when we do an HA failover, or when the pond goes up and down, you know, let's simplify the whole MIB synchronization implementation, and we don't need a persistent store, except for maybe some very, very, very few number of items. Then there is a volatile database implementation in OpenOMCI for the MIB database. That's what I implemented first, and it's also used when we do the audit process. So that's an in-memory only version. You know, it's very fast, and of course doesn't affect etcd at all. So we can adjust as we see needed.
Right. Well, yeah. Okay. Right now we have to focus on getting it to work on multiple adapters. So
yeah.
So I mean, I just wanted to throw that out there that it's
okay.
It's a lot.
Chip.
Yes.
Is those MEs include the PMME?
No, those don't include the PMMEs. The PMMEs come in. I'm actually coding that right now in the PM state machine. So those MEs will be created. So that will add, depending on what we want to capture, they'll probably add about 7 more MEs there. Those are defined, but they'll be created in the database. But the data, as we do gets, you know, interval data, we will never store that information. The only thing we might store in an etcd, if we want it for failover, is maybe when a PM interval was last fetched, you know, a short timestamp. So, but the PM data, all the interval data should never be persisted out to etcd because of the VOLTHA ONU. I think that belongs to the element manager. Okay. And that's some of the stuff I mentioned in the PM and alarm considerations. You know, so as we create the bridge and flow MEs, then we'll actually end up creating some interval PM MEs out there, and they'll be captured, you know, from the PM state machine. And, you know, as I mentioned, we won't be actually storing that PM data at all, or we don't plan to. And one of the other questions we probably need to think about as we start doing alarms, you know, are there any threshold crossing alarms of interest? And can those be deferred until after post 2.0? And for some of the PM data, all of these are 32-bit counters. So some of the PM intervals, such as octets, are going to probably overflow pretty quickly at 10 gigabits. So I'm not sure if that's a concern.
Just really changes your polling cycle. You just need to know that you've only had one rollover.
Well, in OMCI PM, they stick at the saturation level. So that might be something we, you know, of course you can get a lot of the, you know, some of the octet and frame data you might be able to get from 64-bit counters inside the OLT.
Yeah, well, and at the end of the day, especially like octets, I don't know that in a particular path for a particular customer, we need to capture that more than one place. Discards and errors, sure, but those, unless something's catastrophically wrong, those don't move that fast.
Okay. Well, I mean, this was sort of pretty much what I wanted to go over with. You know, I was going out on vacation shortly, and I wanted to try to get as much information and maybe get some conversations started up so that we have this, you know, 6 weeks from now. So if there's any questions or that we can cover right now, or you can follow up later, I'll be happy to do it over email or VOLTHA Discuss or over the phone.
Okay, just one comment on the thresholding. I guess potentially that could be done northbound of VOLTHA, right? I mean, if we're just reporting the raw data up to some collector, that could do the thresholding, I guess.
Yeah, and you know, like 1 or 2 might be like severely errored seconds. That's something that's not going to saturate, but that might be a very important thing to realize that, hey, I've been getting a lot of errors consistently for 30 seconds. So you
right, but I mean, how fast do you need to know that? I mean, I think you know, someone's gonna have to take action on that at some way.
That's why I'm saying, can these be deferred? That way I don't have to code them. So, yeah.
I wouldn't see them as critical, Chip.
Okay. Yeah, I just want to make sure we scope this right so we truly have something that we can deploy as soon as possible. Well, if there's not any other questions, is there any other questions about OpenOMCI even outside of technology profiles?
Yeah, I mean, I've got a few things I'd like to kind of talk through, but it doesn't have to be right now. I just kind of the details of working through the Broadcom ONU and the tasks and the different managed entities that may be different between different implementations. I'd seen your emails and I'd tried a few things, so we could probably get into the details pretty quick if we wanted to.
Okay, yeah, and you know, you have my office phone number, don't you?
I probably do somewhere. I'll find it.
Okay, just email me or call me at any time, except next week.
You're off next week, right?
Yeah, next 2 weeks, but I'll try to watch. I might not be that responsive in email, but I mean, I'd rather answer questions now than letting things back up. So.
Okay. Yeah. Cool. All right. Well, I may give you a call in a little bit after I kind of get my environment situated, and we can look at the hex dump of what's coming out of the alpha and see what it's looking for.
Yeah. I saw some really strange things out of the TNW with response to the supported message types. It gave me the right number, but it gave me completely garbage data. So, good old OMCI. Okay, well, I think that's probably everything, Julie. Unless
Okay.
has a question.
So we'll go ahead. Last call for questions for Chip for today.
Chip, I have a smaller question. I'm looking at the MIP synchronization and using the state machine. So my question is I don't get the many ONU status from this stage because the ONU data is empty. So it's very difficult to simulate the many ONU status into the state machine. So how can to do the input? How can I to do this state machine for testing?
Probably one of the things that you could probably do for simulation is the actual tasks that do like the MIB reset or make the MIB upload next commands. Those are in OpenOMCI tasks. So for a simulation, you can actually drive your own task that just provides that data back. You know, it doesn't actually have to do the OMCI. So if you look at the AdTran ONU, the one I'm working with does not support the OMCI ME. So I overloaded that task just to provide the proper information back so it looked like it did the actual sequence steps. So if you wanted to simulate the MIB upload, is go over to the tasks directory, and there's the MIB upload state machine, or the task, and just override that to provide the data back.
Yeah. I know the MIB upload, and when you're on user coming up. So I mean, after the MIB upload, I need to track every ONU status into the state machine. So I need to track. I need to get every ONU status. So now I cannot get the very data from the ONU in the test. Yeah.
Yeah, and are you testing from an external point, so you need basically an API into it, or is this coded inside the task? Are you trying to access it externally?
Yeah.
To get that, there is not an API. However, all state changes are presented on the Kafka bus as events.
Mm.
And I can look up to what those actually are, because the transition module that implements the state machine capability that I use has some very good output on the logging bus. It's very consistent. So you could actually monitor, you could actually get that from Kafka.
Oh, okay.
You know, not only what state it's currently in but you can actually see all transitions with timestamps as well.
Okay. Can I send you some detail about the state machine? So can you feedback some advice to me?
Okay, sure. Yeah. Just send me what requests you have. So.
Okay. Thank you.
All right, we're at the top of the hour. Any other questions for Chip before we drop for today? Okay, I think that's it. Chip, thank you for the discussion and presentation. I'll go ahead and stop the recording.